Hello guys, welcome back to TechDose, and in this video we will look at count of interesting subarrays problem, which is from Leetcode number 2845. This problem is based on the subarray sum equals k problem, which is from 560, and also continuous subarray sum problem, which is a variation of the subarray sum equals k. So I have already solved this problem in detail, and the link for this problem will be in the description below, so you can learn about it after having solved this problem. Now let's read the problem statement. You are given a zero indexed integer array nums and an integer modulo and also an integer k. Your task is to find the count of subarrays that are interesting. A subarray nums L to R is interesting if the following condition holds true. Let the count be the number of indices I in the range of L to R such that nums I mod of modulo is k and count mod of modulo is also equals to k. Now return an integer denoting the count of interesting subarray, and a subarray is a contiguous non-empty sequence of elements within an array. Now if you consider this nums array with 3 to 4, then you can generate all possible subarrays starting with 3, which is 3, 3, 2 and 3, 2, 4, and you can generate all the subarrays starting with 2, which is 2 and 2, 4, and all the subarrays starting with 4. Now out of all this, you can always find out the interesting elements. Now the definition of interesting element is nums I mod of modulo is equals to k. So modulo value is 2, k value is 1. So if you take 3 mod of 2 is equals to 1, yes. So this is an interesting element. So in this subarray, there is one interesting element. Okay, so the count is 1. Now if you take 1 mod of 2, that means mod of modulo, is it equals to the given k value? Well, yes. And that is why this is a interesting subarray, and you will add plus 1 to the count. Okay, now if you consider this 3 comma 2, you know that 3 is already an interesting element. But what about 2? 2 mod of 2 is 0, which is not equals to 1. So this is not interesting, but this is interesting. So the count of interesting element in this subarray is 1, and 1 mod of 2 is already 1, which is equals to the given k value. So this will also add plus 1 to the count. If you look at this subarray 3 to 4, 2 is not an interesting element, or 3 is an interesting element, 4 is also not an interesting element, because 4 mod of 2 is equals to 0, and that is not equals to 1, right? So definitely the number of interesting element in this subarray is 1. 1 mod of 2 is 1, and that is why it will contribute 1, because this is an interesting subarray. If you consider 2 is not interesting, so the count of interesting elements are only 0. And 0 mod of 2 is 0, which is not equals to this k value, and therefore this will not contribute anything. Similarly, 2 comma 4 will not contribute anything because there is no interesting element. 4 will also not contribute. Whereas if k value was 0, then this 2 and 2, 4 would have contributed. Okay, so the total count of subarrays where the condition holds true is 3, and that is why the answer is 3. I think the solution is clear, right? So if you end up solving for all the subarrays, then that can go to order of n square. And you know that if you have nums length as 10 to the power of 5, then an n square algorithm can mean 10 to the power 10 operations, which is much greater than 10 to the power 8, which is a standard for 1 second. So definitely you are going to get a TLE. You should not go with this approach, right? So we need to do something better than n square. Definitely n log n or n would be so much better. Now in this case, all the elements are within the integer range. Modulo is also within the integer range, and k is always less than modulo. Having known this, let's now look at the idea of subarray sum equals k, which will help us solve this current problem. Now if I was given an array, let's say I was given a certain array, I don't know the elements, but I have given you the prefix sum representation of that array by skipping some of the elements in the middle, which I don't care, right? Now if I ask you, based on this information, tell me the number of subarrays with sum equals to x, then you will say that this is one subarray with sum equals to x, because prefix sum means from the beginning you are adding the sum, right? This is another subarray, and this is the third subarray, right? If I ask you about number of subarrays with sum equals to 0, then you will answer that this is that subarray, this is another subarray, and this is the third subarray. So there are 3 subarrays. And how were we able to find it out? Well, let's say that I was here where the prefix sum value was equals to x. Now if I want to find, let's say, a subarray where the subarray sum ending at this index must be equals to, let's say, some value 0. Then I want to find out on the left side if there is a value in the prefix sum which is equals to the current sum minus the target sum. Is there any x minus 0 on the left hand side? Well, yes, x minus 0 means x. So yes, there is an x and there are two x's. So there are two subarrays ending at this current index k where the subarray sum will be equals to 0. More formally, if I take the second example and if I say that my prefix sum here is equals to x. Prefix sum here is x. Now if I want to find out, are there any subarrays where the subarray sum in the middle is x minus y, then what should be my target sum on the left hand side? My target sum should be equals to my current sum which is x minus whatever sum I want to find which is x minus y. So that will boil down to finding y on the left hand side. How many times y has occurred? Y has occurred 2 times. So that means there will be two subarray. One will be from p plus 1 to s and another one will be from r plus 1 to s. These two subarrays will end at s where the subarray sum will be equals to x minus y. That is how you will find it, right? Now for this x there is one such subarray and therefore the total count is 3 in this case, right? So I hope you can also find out how to find the number of subarrays with sum equals to y. It will be 2, which is this one and this next one, right? If you look at this third example, here I have given the number of subarrays with sum equals to y. So if let's say this is your prefix sum which is equals to x, then you want to find how many subarrays are there on the left side so that the sum is equals to y. So that means your target sum on the left side in the prefix sum should be equals to my current sum x minus whatever is your goal to achieve which is y. So that means I am searching for if there are x minus y in the prefix sum on the left hand side, and yes, it has occurred 2 times and therefore there will be 2 subarrays ending at this current index with a sum where the subarray sum will be equals to y. So I think this point is clear. This will be the logic which we will be using in this problem to solve. Now let's see about the interesting subarrays. Now in this problem we are given the array, and what we can do first hand is I can convert the given array to an is interesting array, and the is interesting array will be simply like a true or false or a 0 or 1 value, where the 1 value will determine that the corresponding element is interesting, otherwise 0 will determine it is not interesting. Now the definition of interesting element is the given element mod of modulo value should be equals to k, then it is interesting, otherwise it is not interesting. So 2 mod of 3 is equals to 2 and therefore it is interesting. 10 mod of 3 equals to 1 which is not equals to 2, therefore it is not interesting. And accordingly I have filled up the value. Now using the previous logic of subarray sum equals k, we can actually count the interesting subarrays. You know that if you have solved this problem, you will be doing this with hash map simply, right? Because you need to know how many times a given prefix sum has occurred. Have you already seen that sum with the frequency have to be maintained, prefix sum with its corresponding frequency have to be maintained in the hash map, so that you will be easily determining if x minus y is even present on the left hand side without having to parse this entire array. Just look up the map and you can answer this, right? So simply that will be the trick that we'll be using here. So I will be using a prefix sum and the frequency, okay, and this will be your map, and I will be moving from left to right. I'm just giving you an idea. I'll give you the dry run on the next page. So if I see a 1, then you know what should be my target sum. I want to find out if this is the index I, then I want to find out how many subarrays ends at this index I which is interesting. That's what I want to find, right? So how many subarrays ends at this index I which is interesting? So in this case I will be seeing the prefix sum. What is the prefix sum value? It will be 1. Okay, so prefix sum is 1. That means you can say that my current sum or prefix sum is 1. What is the target that I want to achieve? Let's say my prefix sum is called p is given. Okay, so p is equals to 1 in this case. The target sum, that means the subarray sum, you can say in the middle, what I want to achieve, it is equals to k. It is equals to 2 in this case, right? So what I want to get on the left hand side in the prefix sum array, moving from left to right, what should be that value? It should be p minus k that I want to get on the left side. Okay, so when I move my prefix sum from left to right, I want to find out p minus k. Is it present on the left hand side? So you have 1, k value is 2, minus 1 is not present on the left side. Fine, now we are playing with modulo here all the time. We are playing with modulo because the count of interesting element mod of modulo should be equals to k. Okay, that means just finding out whether this happens on the left side is not enough. Mod of the given modulo value 3 should be equals to the given k value. Is it equal or not equal? That's what I want to check. So in this case, if you see 1 minus 2, it will be minus 1. Mod of 3, is it equals to 2? Now, in order to convert this negative value to positive value, because I don't want to handle the negative value, let's say, then what you can do is use the modulo arithmetic. So 2 mod of 3 is equals to 2, or you can also write that 2 plus 3 mod of 3 equals to 2, or you can write 2 plus 2 times 3 mod of 3 will be equals to 2. So if you add the same value any number of times by which you are taking the modulo, the final modulo answer is not going to change. The remainder will never change. Okay, so using this logic, if you have a negative value or whatever, you know that if you are always taking the mod while parsing the prefix sum from the left to right, I will be increasing the prefix sum and cycling it in the range of 0, 1, 2. Because prefix sum going beyond this 3 does not make sense, because everything is in modulo operation, right? So I'll be maintaining all these values from 0 to modulo minus 1. If I am doing that, then I may end up with some negative value as well. And for that reason, I have to add to my target, I have to add a modulo value by which I will be taking the modulo, and there will be no effect to the remainder. Okay. So when I am calculating for 1 minus 2, then I will be exactly calculating for 1 minus 2 plus 3 mod of 3. And what is this? 1 minus 2 is minus 1 plus 3 is 2. 2 mod of 3 is 2. So have we seen a 2 on the left hand side? Well, we have not seen anything, right? We have not seen anything. So that means there will be no interesting subarray ending at index 0. And by the way, before starting, I can always push a prefix sum 0 with the frequency 1, because that will be handling your case of getting the subarray sum, whatever was your target. Let's say I was asking about the number of subarrays with sum equals to x. Then if you have inserted a 0, then you will always be able to find, if your target was x and your current sum is x, that means you are searching for x minus x, which is 0 on the left hand side. That sum may not have occurred, but 0 is always the start point. It is always present at least at the start point. So to take care of that, we can insert 0 right in the beginning. As soon as you see a 1, after having seen this, I will be inserting a 1 also in the map, right? So there is no 2, by the way, on the left hand side. And when you move to the right, then you have a 0. That means the prefix sum will not change. It will be 1 plus 0, which is 1. Again, you do the calculation and it will come as 2. So 2 is not present on the left side. Again, you move to the right hand side, the prefix sum value becomes 2. So what I am finding as a target on the left hand side, 2 minus 2 plus 3 mod of 3, which is equals to 0. So is there a 0 on the left hand side? Yes, there is a 0, because 0 is always the start point, right? So that means this subarray is an interesting subarray. And likewise, we will be proceeding. So I think you have got the idea of what we are trying to do. Right now, in this case, we can actually optimize this solution. We don't need this is interesting array. We can produce these values on the go while parsing, and we don't need the prefix sum array as well. We can just have a single variable. And I hope you have understood that why we are maintaining this cycle of values instead of just adding all the values. I mean, it can go out of bound as well. And since I know that all the values that I care about is 0 to mod minus 1, therefore take modulo of all the values, cycle it back. And we have also understood about the definition of interesting element and how to actually solve this problem by using the subarray sum equals k logic. Now let's see a dry run with the prefix count, subarray sum equals k logic plus the hash map technique. Now in this particular case, I am given the array and I'll be maintaining the prefix sum, or you can say prefix count, and the interesting subarray count, which will be starting with 0. My modulo is 3, my k value is 2, and my prefix count is will be equals to p, This means that my target sum, if my prefix count means the prefix sum value, if at any point is p and the subarray that I'm looking for is, let's say, k, then what I'm looking for on the left hand side is actually equals to p minus k mod of modulo value. This is what I'm looking for. But since I want to also handle the negative values, so for that, so that I don't end up with negative value, I will add modulo. We know that this modulo addition has no effect, right? So this is what we are searching for on the left hand side, and we can maintain whatever we have seen as a prefix sum moving from left to right on the left hand side by using hash map. Okay, so this will be my entire idea. Now let's see the dry run. Initially I will be pushing a zero sum with the frequency 1, because I will say that I will always have a prefix sum equals to 0 right in the beginning without including any item, and that is true. Now let's see. The current item being 2. Is it an interesting item? First of all, you have to find it. So my prefix counter is 0, which is equivalent to prefix sum. My prefix counter is 0. 2 mod of 3 is equals to k value 2. So this is a interesting element. So add 1 to it. Now add this entry into the hash map. Okay. Now the third step is find the target sum on the left hand side. What should be the target sum? Current prefix sum is 1. Prefix sum is 1 minus k. Right, so the k value is 2, plus, just to make it positive, add the modulo value, take the modulo value mod, and this value is going to be minus 1 plus 3, 2. 2 mod of 3 is 2. Fine. So is there any 2 on the left hand side that you have seen? No, there is nothing like that. So that is why it will not contribute to interesting subarray, and we have to move forward. When you see this 10, then 10 mod of 3 is 1, which is not equals to 2. So your prefix count is not going to change. And now I will be incrementing the frequency because I am seeing it for the second time. Now again, you will be searching for the exact same value. That means 1 minus 2 plus 3 mod of 3, which is 2, and 2 has not occurred. So therefore, it will not contribute anything, right? It is not interesting. Now there is no interesting subarray ending at 1 as well, right? So if you look at this 5 mod of 3 is equals to 2. So this is interesting. It will be incrementing the prefix count by 1. So take 2 frequency as 1. Now you need to search 2 minus 2 plus 3 mod of 3. That means 0. How many times 0 has occurred? 1 time. So to my interesting subarray, add 1 and this becomes 1. Okay. Right. I think this is clear. Now there is one interesting subarray ending at 2, which is the subarray from 0 to 2. Now simply move on to the next item. 8 mod of 3 is 2. So this is interesting. Increment the counter to 3. Now I know that I will be maintaining all the values of the prefix sum and even all the values in the range of 0 to mod minus 1. So I'll just take mod with the modulo value and this will become 0. So I can increment the frequency of 0 and make it 2. Okay, make it 2. And now the next thing is you search for 0 minus 2 plus 3 mod of 3, which is equals to 1. So is there 1 on the left hand side? Yes, it has occurred 2 times. That means there are 2 interesting subarray, and so increment the frequency to 3. And if you look at it, one subarray is 2 to 3 and another subarray is 1 to 3. 2 to 3 has 2 count, so 2 mod of 3 is 2. 1 to 3 has 2 count of interesting elements, so 2 mod of 3 is 2. Now let's go to the next element, which is this 17. 17 mod of 3 equals to 2. Okay, so you can increment the prefix count to 1. So at 1 increment the frequency. Now 1 minus 2 plus 3 is what we are looking for, and this will be equals to 2. So how many times have you seen 2? 1 time. So it will increment the interesting subarray by 1. It becomes 4. And that's it. We are done. So the interesting subarray count is 4, which is our result. And I hope this entire approach is clear. Now if you look at it, we have taken extra space, which is the hash map, which can be considered order of n. And we are just parsing the array exactly 1 time. So order of n for that. So time complexity order of n, space complexity can be said to be minimum of n comma modulo, but you know that the modulo value is 10 to the power of 9 and the n value is maximum 10 to the power of 5. So even if you end up answering order of n, it will be absolutely fine. No need to say the detailed minimum n comma modulo, right? Because n max is way smaller than your modulo max. So I hope this is clear. Let's now look at the code. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. In this problem, we are given the nums array, modulo and k value. So these are the variables that I am assigning, and then I will be taking the mod frequency, which is basically your prefix sum and how many times it has occurred. I will be initializing the zero sum frequency with 1 because I will always be starting with prefix sum 0, right? And then I will be processing for all the elements one by one. So if I see a current element and if I take mod of given modulo value, if it is k, then this means it is an interesting element. And if it is interesting element, I will increment the prefix counter because I am treating the values as zeros and ones. If it is 1 means it is interesting, if it is 0 means it is not interesting, according to what I explained. Now I will always maintain the prefix count value in the range of 0 to modulo minus 1. We will cycle back and then we will be searching for the target element. So as I already said that if your prefix sum is p and your target that you are looking for is k, then on the left hand side you should look for p minus k. And since you want not to have negative values, so you will be adding a modulo to it and take mod with the given modulo value, which will never change the answer, right? And that is what we are doing here. Prefix count minus k plus modulo mod of modulo. If this is already seen, then this means an interesting subarray, at least one interesting subarray, ends at the current index, right? And the frequency of how many times you have seen the target sum on the left side will be added to the interesting subarrays. And after that, whatever happens, we will be incrementing the prefix sum frequency and going to the next position, right? After parsing everything, the interesting subarray will be returning the total number of interesting subarrays. So I think this is simple to understand. If you still have any doubt, then feel free to comment below and I'll try to help you as soon as possible. See you guys in the next video. Thank you.